Hello everyone, welcome back. Oh, oh wait, I need to put my mic. Hello everyone. Can you hear me? Looking at the live chat. Please let me know if you can hear me. Awesome, awesome, awesome. So, hello everyone. I'm Sai Avinash. I'm currently an studies at Google Dublin. And in this lecture series, I'd be doing live problem solving on like Codeforces or various other platforms in general. So in this class, I'd be teaching. I'd be actually solving a greedy problem. It's a fun problem, live in front of you, and it's a good problem. It shows you the power of greedy over DP. I'll do a DP approach as well. All right, let's get started. So a little about me. I'm an All India rank 4 at CodeChef. I'm a 7-star coder there, and my max rating is an international master at Codeforces, and I'm currently a master there. And I'm previously interned at Uber, and I'm also a CodeChef Standard finalist. The subjects that I take are discrete maths, dynamic programming, graphs, and a lot of other combinative programming topics like greedy and so on. So use the code SciLife to get a 10% off on the Unacademy Plus subscription. Awesome. So if you think you got don't forget to like the video if you think it was useful to you, and do share it with your friends if you think they've just started with competitive programming and it could be useful to them. And don't forget to subscribe if you want live updates on the latest classes. All right, let's solve problems. Yeah. Okay. This is the last problem. One second. Give me a minute. So this is the easy version of the problem, as they say. There's a harder version which we'll get to. First of all, I hope I'm audible and everything's clear, right? Awesome. This is going to be a bit. I know it's mentioned easy, but it's harder than the ones that I've done in the last class. So bear with me. So what's the question? What's the problem? There are n portions in a line with portion 1 on the far left and portion 1 on the far right. Each portion will increase your health by AI when drunk. AI can be negative. Meaning, like, if you drink a portion, your health is going to be increased by AI. Meaning, if AI is negative, your overall health could reduce as well. So you start with 0 health and you will walk from left to right. From first portion to last one. At each portion, you may drink or ignore it. Like, you can choose to drink, or like you can maintain your health and go ahead. You must ensure that your health is always non-negative. What is the largest number of portions you can drink? So the input is the form, like you're given the number of portions, and you're given n portions, telling what the change in health after drinking that portion is. Right. Now you need to output a single integer, the maximum number of portions you can drink without your health being negative. All right, let's look at the solution. Let's look at the test case. So first you can, so here, the answer is 5 apparently. Let's see why. So you can drink 4, you can drink 1, you can drink -3, 1, and -3. You can't drink all of them. Why? Because if you take 4 and then -4, your health is going to be, initially your health is going to be 4, then it's going to be 4 minus 4, 0, plus 1, 1. And if you do a -3 here, it's going to become -2, and that's not allowed. You want to keep your health greater than or equal to 0 at all times. So if you skip this -4, it seems like a big number, so let's skip it. So 4, Then 1 becomes 5, 5 minus 3, 2, 2 plus 1, 3, 3 minus 3, 0, and 0 is allowed. So we are safe by skipping this and choosing the other 5. Right. So essentially the question is choosing the largest subsequence where no prefix sum is less than 0. I'll just draw out the example for better understanding. So what are you given here? What are you given here? Okay, oh. So you're given a bunch of numbers here. 4, minus 4, 1, 3. What are the numbers? 1 minus 3, 1 and 3. 1 and minus 3 gets out. So you can just this portion, and still be done with it. Like you're still good, you're still healthy. But you can choose 2 more portions, so you'll choose it because you want to maximize the number of portions. As simple as that. You can't choose this one, you can't choose all of them because here the initially health is 0, then 4, then 0, 1. 1 minus 3 is going to become minus 2, and this is bad. But if you skip this and choose the other 5, you have 4. Initially start with 0, right? 0, 4, 5, 2, 3, 0. Health was never 0 at any point. Never less than 0 at any point. So you're good here. Since you can't do 6 and you can do 5. So you can't pick 6 portions, but you can pick 5 portions. So 5 is your answer. Got it? Is this clear? Is the question clear? Is the question clear? Any doubts on the question in the live chat? Awesome. Awesome. So how do you do this? How do you do this? So we'll take a DP approach first. So what are you given here? Essentially given A1, A2, A3, A4, and so on. Right? That's what we're given, right? Yeah. Now you need to pick a bunch of these numbers, A1, A2, A4, and so on. Now, say you pick A1, A2, A4, and A7. Say we get this. Now we need to make sure that A1 is greater than or equal to 0, A2 is greater than or equal to 0, A1 plus A2 is greater than or equal to 0. A2 can be negative, but A1 plus A2 should be greater than or equal to 0. A4 plus A1 plus A2 should be greater than or equal to 0. The sum of all numbers should be greater than or equal to 0. All these numbers. Anyway. Yes. Choosing only the positive numbers will serve your purpose. Will do your job. But since the goal is to maximize the number of portions, you need to add in a few negative numbers because you want the correct answer. Like you just want to maximize as much as possible. You don't want to be as healthy as possible. That's not the goal. You just want to maximize the number of portions. And that's it. That's why you need to choose negative numbers. All right. So let's try to look at the state. Say given A1, A2, A3, so on till AN. This is your input, right? Let's look at the state. Let dp of I, let max health, let's define this. Max health of n comma I or n comma I determine what is the maximum health you can get by picking exactly I portions out of the n portions. Okay? What is the maximum health that you can get by picking exactly I portions out of n portions? And I'll tell you why this is required. Yes, exactly. Vimal is exactly, that's the main thing. There are exactly two possibilities. Either the sequence, the number is either present in the sequence or it isn't present in the sequence. So let's see how this gets recursive. Max health. And we need to add another condition where, oh, hi Huron, you're back. Calculate all positive and sort negative numbers and then add as many as possible. This will be wrong. Okay, let's look at one greedy solution which is wrong. Oh, wait. But still, like, how would you know if adding would make sense? For example, you have -1, -2, 3, 4, 5. And sorry, there's no 5 here. -2, -2 again here. Now, you add all negative numbers. You add all positive numbers, 3 and 4. How do you know? Like, you can, since it's a small example, you can directly check if it's possible to add or not. But when you're given a big array, how do you check if adding minus here? You can't add -1, right? Because it's the first number that would make a sum negative, prefix sum negative, right? How would you check it if in a big array, some small numbers are in between? You don't know adding it would make it better or not. How would you quickly check? There would be some complications involved. You might be able to do it, but I don't know of a quick way to do it. Like, if you think there's a quick way to do it, please let me know in the chat and we can discuss that too. All right. Anyway, let's look at this. Let's look at a solution here. But that it could be possible. So do let me know in the live chat. So max health of n comma I. Again, there are two options, right? You either take the nth one or you don't take the nth one. Right. If you don't take, then max health of n comma I is same as max health of n-1 comma I. It's as good as the nth element that exists. If you take, it's basically an plus max health of n-1 comma I-1. All right. What's the complexity of the solution here on? Like, as I mentioned, like, you don't know if adding. How will you check if adding numbers would not make any prefix less than 0? Because the order of the numbers matters, right? Order of the numbers matters. Like, it should be in the same order like this. For example, if you're given 1, -1, 3, 4, this is your input. Meaning, you can't pick the whole sequence saying, you can't say my answer is 3, -1, 4. No, the order should be preserved. You either pick -1, 3, 4, or you pick 3, 4, or you pick 3, or you pick -1 or something. But the order should remain the same as it's in the sequence, right? So you go from left to right no matter what. You can't just skip numbers. You can't just change the order. Anyway, all right. So max health of ni, it's either you don't take it, max health of n-1 comma I, or you take the nth portion. In which case it will be an plus max health of n-1 h-1. But we just need to add a small other condition here that we can add. This is valid only if this should be greater than or equal to 0, right? This should be greater than or equal to 0. If it's less than 0, you can't reach this. Meaning, if the maximum health you can reach from, what do you say? If you take the nth item, maximum health that you can reach by picking I-1 out of n-1 items, if the maximum health you can get is negative already, meaning you cannot get better than 0, greater than or equal to 0, it means that you will never take the nth item. Because if you take the nth item and if you want I-1 items from here, that is never going to happen because it's invalid in the sense that your health is going to go negative. If this is negative, don't choose it at all. If it's not negative, then just max health of a state can be negative, but it just means that the state is invalid. I will show it to you in code and you'll understand better. And that is it. That is the solution. Nothing else. Yeah, sure. The question is basically 1526C1. That's the question. All right. Let's take the input. First of all, any doubts with the solution so far? Any doubts? Actually, sorry for like just proceeding with the asking. Any doubts with this question solution so far? So I'll just write the pseudo case here, like, and we'll decide how we gonna get the answer in the end. Basically, max health n comma I is equal to max of, if you don't take the nth one, it's simply max health of n minus 1 comma I minus 1. Otherwise, if mh of n, sorry, there's no I minus 1. Like, this is don't pick nth, pick nth. This is essentially an plus mh of n minus 1 comma I minus 1. That clear? Any doubts? Awesome. Awesome. Let's start coding. All right. How to calculate the answer in the end? I'll show you how to calculate. It's pretty straightforward once you get this. Scene AFI. Now let's declare the DP. Vector LLDP and let's declare all of them with -1 first. Okay. Awesome. For int I equals 0, I less than n, I plus plus. For int taken equals 0, taken less than or equal to I plus 1, taken plus 1. Like, since it's 0 indexing, that's what I'm doing. Okay. Now, if I equals 0, that's a special case. Otherwise, if I equals 0, dp of I 0 equals 0. Like, if taken equals 0, dp of I taken equals 0. Like, if you're not taking anything, there's no health lost or gained, right? So just write that. Else, there are only two cases. If I equals 0, taken can be equal to 1. dp of I taken equals AFI. It's very simple. Awesome. In fact, we can move this outside. Meaning, if taken equals 0, dp of I taken equals 0. Continue. So taken, if taken is 0, it's going to be here. Like, no matter where you are in the game, like where you are in the process, dp of I taken would be equal to 0, right? If taken is 0, like if you're not taking anything, there's no health gained or lost. All right. Now, here taken is at least 1. So if I equals 0, if you're taking the only element, dp of I taken would be AI. Otherwise, dp of I taken is equal to LL take, if you take the ith one. If you take the ith one, if you take I, it would be, first let's write don't take, then it'll be easier. Okay. dp of I minus 1, taken minus 1, taken. LL take, let's initialize this to -1e9. Now, if dp of I minus 1, taken minus 1 is less than 0, sorry, if it's greater than or equal to 0, then take equals max of A of I sorry, it's basically a of I plus this value. We discussed that, right? We discussed that here. An plus max of, like, max health of n minus 1 comma dp minus 1. I'll actually replace dp with max health. Now, max health of I taken equals max of take, don't take. That's it. That is very straightforward. Now, if you want to compute the answer, how would you compute the answer? Int for int I equals n, take equals n, take greater than equal to 0, take minus minus. If max health of n minus 1 is the last index, and take is greater than or equal to 0, meaning you are following all the rules and you're taking, like, I'll replace this count x. Okay, you're taking x portions, very by following all rules. That means by making sure no prefix is greater than or less than equal to less than 0, right? You're doing that. So int answer equals 0, answer equals x, break, see out answer. Is this clear? Is this clear? Any doubts with this? So first I took the input, and then max health is the dp, like we just recursed over the smaller elements. If you've seen my previous dp videos, this should be pretty straightforward. So you either take the last element. You take the last element only if it's possible to take it. Like if the previous health value is greater than or equal to 0, then only you move to the state. Then only you take. Otherwise, you declare it to minus 1e9. Vimal, I know, like, I understand that, like, you want to make it like, if max health of I 0 comma taken, it's less than 0, it's already an invalid state. So you should not make it 0. Making it 0 would make it a valid state, right? If any state is less than 0, that means if AI is less than 0, this would already be an invalid state. For example, if don't take, for example, if max health, ideally we want to check max health as well. Like if we check there's no harm, like we can declare this as minus 1e9. If max health of I minus 1 taken greater than or equal to 0, don't take equals max health of, we can do this as well. But here you should not make max of this comma 0, you should make max of this comma minus 1, because we already signified that, told that if a state is 0, if state is less than 0, like max health is less than 0, later when we are computing it, we are assuming that it's minus 9. We are never taking it if it's less than 0, right? We are already assuming that if it's less than 0, it's a state that's not possible to visit. Like, so we are discarding that state either way. Is that clear? Any doubts with the solution? Any doubts with the solution? Awesome. Sure, any doubts, please let me know. Awesome. Was clear? All right. Let's look at the greedy solution. What do we have here? Like, I don't have a solid proof for the greedy solution, but well, I hope it's intuitive enough. I really don't have a solid proof for it, but let's look at the solution first. Note that this is n square. This is n equals 2000, meaning the complexity of the dp was n into n. Like for each n, you're going up to I. So the sum of the first n natural numbers is n square of n square. And at each step, you're doing only an O1 operation. All of this is just an O of 1 operation. Like you're not doing anything costly. So the complexity of this would simply be O of n square. 2000 square is 4 into 10 power 6, which is within time limits. Now, let's look at the next question. Awesome. The harder version, where n is up to 2 into 10 power 5, meaning you cannot do this dp, meaning n square is gone, you cannot do it. How would you do this problem? How will you do this problem? How will you do this problem? Let's look at it. So first, what do we have here? We have 6, 4, minus 4, minus 3, 1, minus 3, 1, minus 3. All right. So what we're going to do is keep a set. Just keep a set of active elements, meaning first we have 4, we put in 4. Say we have minus 4, we put in minus 4 as well. Our sum is currently 0. We have 1, we put in 1. Now we encounter minus 3. We encounter minus 3, but we cannot put in minus 3 because our current sum is 1. Our current sum is 1. There are 3 elements in the set. Our current sum is 1. And if you put in minus 3, the sum is going to go negative. So we are better off removing this minus 4 and having minus 3 instead. Remove, add minus 3. Now we have a 1. Our sum is now 1 plus minus 3. You removed minus 4. It's basically 2. Now you're adding 1 again here. Can you add 1? You can. Why not? Plus 1 plus. Can you add 3 here? Minus 3 here. You have 1 here. The sum is 3, right? So far. 3 so far. So you can add minus 3. So our set would, in the end, this is how our set is going to progress. First you're going to have 4, then you're going to have minus 4, then you're going to have 1, then you're going to have, can you have minus 3? You can't. So you pop the smallest number out. If it is less than minus 3, you're better off popping it out. Then you put in minus 3 here. Then you can put 1 here. Then you can put minus 3 here. The size of our set is 5, and that's our answer. Let's look at it again. Let's look at a bigger example. Minus 5, 3, 7, minus 12, minus 5, minus 7, 8, 2, minus 10. Let's look at this example. We have a big box here where we're going to put in our elements. First you have minus 5. You can't put in minus 5 because the sum is going to go less than 0. All right. Now you're at 3. You can put in 3. You're at 7. You can put in 7. Now minus 12. Can you put in minus 12? So if you can pop out the smallest number in the set is 3. Minus 12 is less than 3. So you don't want to put minus 12. You're going to skip minus 12. Can you put in minus 5? Yes, you can put in minus 5. Can you put in minus 7? Well, You can't, because 3 plus 7 minus 5 is 5. If you put in minus 7, it's going to become minus 2. But you can put in 7, minus 7 if you remove minus 5 outside. But why would you remove minus 5? Like minus 5 is less than, like, it's a number which is greater than minus 7, meaning it's minus 5 is doing a better job than minus 7. So you want to have minus 5 instead of minus 7 instead. You don't want to remove this to put minus 7, because that's only going to make your situation worse. Can you put an 8 here? Yes, you can. It's a positive number. Why not? 2. Yes, you can put 2. Can you put in minus 10? Yes, you can. Because 3 plus 7 is 10. 10 minus 5 is 5. 5 plus 10 is 15. And you can put a minus 10 here. Let's add a few more numbers here. Minus 12. Minus 3. Minus 7. Minus 9. Let's see if we can put any of these numbers here. A few more portions are added to the list. Let's see how this is going to be here. Like, same thing. Till minus 10, everything is going to same. The box is going to look like this only. You know that our answer is at least 6. Okay? Alright. Now, can we add minus 12 here? Can we add minus 12? The sum here is currently 10 minus 5 plus 10 minus 10. Currently, the sum is 5 so far here. If you want to add minus 12 to this, the sum is going to be minus 7, which is going to be bad. 5 minus 12. It's going to be bad. But you can add 12 by removing this 10. Removing this minus 10, you can add in 12. But you would not do that. Why? Because minus 10 is going to do a better job than minus 12. Right? Like it's gonna increase our sum. Minus 12 is not gonna increase our sum, but compared to 12, it is. Like it's too bigger than minus 12. So it's gonna increase our health. So that's what we want to keep minus 10. Minus 3. Can we keep minus 3? Yes, you can keep minus 3, because 5 minus 3 is greater than 0. Greater than or equal to 0. You can keep minus 3. Can you keep minus 7? You cannot keep minus 7 right now, but what happens if you keep minus 7? What is the current sum in this? If you look at it, the sum is 2. If you add minus 7, 2 minus 7, the sum is going to go negative, right? Okay. But what to do in this case? So we have minus 10 here. If we remove minus 10 and then put minus 7, we are in a better situation, right? We are getting a benefit of 3. So the idea of this is having the negative numbers towards the end is always a benefit. Plus, you want to have smaller negative. Yeah, you want to have like, by smaller negative, I mean minus 2 is smaller than minus 5, but like the absolute smaller. If you want to have minus 7 instead of minus 10, right? Like if you can have minus 7 sometime later and minus 10 by erasing minus 10 which came earlier in the sequence, you can remove that minus 10 earlier and put in minus 7, and that's gonna make your situation better. So this is going out. This is essentially going out, and minus 7 is in. Now, so if you do this, what is going to be the sum? You can see that 3 plus 7 minus 5 is 5, plus 10 minus 3 minus 7. The current sum is going to be minus 5. Sorry, plus 5. Plus 5. The total sum currently is plus 5. This is gone. Now you want to put in minus 9. Can you put in minus 9? Well, 5 minus 9 is minus 4. So you can't put it directly. You probably have to remove minus 7 or minus 5 or some number like that. Well, since it's the end, you can do it. But like you're just removing a better number and putting a worse number. Your answer is going to remain the same, but like you don't have to do it because the answer is going to remain the same. So like ideally you would want to remove minus 7 and put in minus 9. And then your end result would, and sum would be, health would be smaller, but it's not changing anything. So let's keep our health as high as possible while keeping given the number of elements in our set is maximum. So this is our answer here. So the answer for this sequence is 8. And this is what we're going to write in our code. We're going to implement this in our code. Is this clear? Is the solution clear so far? Is the solution clear? Any doubts with the solution? Any doubts with the solution? Yeah, great, awesome. If there's any point which is not clear, or do you want me to re-explain, I'd be happy to re-explain. So please let me know if it's not clear. Clear? Awesome. So how do we do this efficiently? What are the things that are needed here? So basically, you need to maintain an active set, and you want to like frequently ask what is the smallest element, which is like, for example, in this case, you wanted to ask. For example, in this case, you wanted to ask what is the smallest element, -10. You want to get that quickly. You don't want to iterate through it every time, right? You want to get it quickly. So one data structure that supports it is a set or a priority queue. Like priority queue, it's the fastest. It's one of the quick implementations of a heap. I will tell you the complexity. So the complexity is like, I'll show you. So this is our DP approach, which is O of n square. Everything till here is going to same. Going to be remain the same. Set int active set LL. I'll just make this long for now. Yeah. LL current sum equals 0 for int I equals 0, I less than n. If current sum plus AI is greater than or equal to 0, then just add it to our active set. That's what you did, right? Active set dot insert A of I current sum plus equals A of I. Else, this is where our issue comes. Let's get the smallest element in our active set. Int smallest. How do you get the smallest element? The set's beginning iterator points to the smallest element in the set for the definition of the smallest that you provided to the set. Active set dot begin. Active set dot begin. That gives you the smallest element. And note that when you come here, since wait one sec. We just need to add another case where if active set dot size yeah all right, else just leave it. I'll tell you what each of these means. Smallest element equals this. Now if A of I is greater than smallest element, that means you're better with having A of I instead of that smallest element which is in the active set, right? That's what you do it. You add AI. Active set dot erase smallest element. Active set dot insert A of I. As simple as that. Now since you've added it, you need to update the current sum as well. Current sum plus equals AI. Current sum minus equals smallest element. I'll just write it here for more convenience. So first case, if you can add this current AI, add it blindly. Now, if at any moment, or rather, like note that I'm adding this condition because, oh wait, what happened? Yeah, okay. So this, if you can add it. Now, if you can't, like at this point, you cannot add it directly, meaning, okay. And if active set has a size greater than 0, if it is equal to 0, it means that your current sum is also equal to 0. Now adding this element would make it negative and you cannot do anything about it. So you just leave it aside. Now we have the smallest element. If you can, now smallest element, now if the current AI is greater than the smallest element, It means that AI having AI is better than having that smallest element now. In this case, AI was -7 and the smallest element was -10. Since -7 is greater than -10, here, for example, in this case, smallest element equals -10, AI equals -7. Better off having AI instead of. That's it. So you erase smallest element and then you add AI. As simple as that. Got it? And towards the end, the answer would be answer, active set, that size. This is our answer. This is our answer. Got it? Awesome, awesome. Any doubts so far? Is there anything you want me to re-explain? I'd be happy to do so. Got it? Okay, I know. Any doubts with the solution so far? Are there any questions? Awesome. So I'll just briefly explain how we went about this problem. So first we had the easier version where n was up to 2000, and we figured that like we tried to do the DP approach where we wanted to get the maximum. What is the maximum health that you can get by considering the first n portions, but you're picking only I of them? What is the maximum health you can get? And then we found that we either take the ith one, we take the nth portion, or you don't. So you have two options, and you have two lower states you can visit with the DP, right? And then we similarly figured out the answer. Like once you figure out the recurrence relation and the choice that you need to make, it's just writing out cases now. Like, can I go here? Can I go to the state? Yes or no? If I can't, I shouldn't go there. I need to declare a default value, and I need like decide what a default value and what a good default value is. And towards the end, figuring out how that DP is actually helpful, like in computing the answer. Like you iterate over all the states and figure out which state is greater than 0, which state had a health greater than 0, and you printed out the maximum state. Right? Awesome. Maximum state. Then we figured out that the complexity was simply O of n squared, because at each state you're doing an O(n) operation and there are n square states. The complexity would be O of n squared. Great. Now the harder problem had n up to 2 into 10 power 5. N square is not feasible there. What do you do? So what we do here is we try to think of a greedy solution. So here we try to maintain an active state, an active set, which contains all the portions that you've ranked so far by following the rules, right? By following the rules. So we keep adding it to our active set while we can, but if we can't, we remove this. We look at the smallest number in the active set. Now, the current portion, if you feel that hey, adding the current portion is going to make my situation better, adding the current portion and removing that smallest portion, like for example here, adding -7 and removing -10, make my life easier later, like make it better. Like, can I potentially take more portions later on in the sequence? If I can, if that's only making it better and not worse and never worse, you should do it, right? So you do that. That's greedy. If it's making a situation better, keep doing that. It's never making a situation worse. So you keep doing that, and in the end you have an active set. Note that at each point you're either adding it or removing and adding it, meaning you're never reducing the size of the current set, right? You're never reducing the size of the current set, and this is only increasing the current sum. This is only increasing the current sum. Got it? Okay. When I ask that such ideas come only if you have done such kind of similar problems earlier. Greedy. Well, it certainly helps to have done similar problems before, but this doesn't necessarily require you. Working out examples help, but uh, just to let you know, I didn't get this during the contest. And I didn't have time to do this in the contest. So yeah, uh, I personally didn't get it either. So even after you practice, you might not get it, but again, practicing increases the probability to large amounts. I just did the DP approach, but I didn't do this within time. So yeah. So, but as I said, doing similar problems certainly helps. Certainly helps. It does. It helps a lot. All right. Any more doubts in the solution? Any more doubts? Please let me know in the live chat if you have any doubts. Awesome. In that case, I will end this class then, without wasting any more time. I hope this class was useful to you, and if you think it was this class was useful to you, if you think it was like educational to you, do drop a like if it was useful, and do share it with your friends if you think it's going to be helpful for them, and don't forget to subscribe to get live updates on the latest classes. All right, see you in the next class.